is intercept form. I'll go back in a second. Okay, so the intercept form is set up in a way that looks like this, okay, where you have factors. So you might also hear this referred to as factored form. Okay, but if your quadratic function is written as factors, your long-run behavior is still based on your leading coefficient. So if a is positive, your graph opens up. If a is negative, your graph opens down. Your vertex now, and again, this is where the SAT comes into play because it'll ask you to find the vertex no matter which of these three forms you use. But the vertex, if you're dealing with intercept form, is found by taking the average of the intercepts because of the symmetry of the graph. The x-coordinate of the vertex is always going to be halfway between the two x-intercepts. And so if we jump down here to identify the x-intercepts, are the coordinates p0 and q0. What that means is the vertex is going to be halfway between those two. It's the average of them. So the x-coordinate for our vertex is going to be p plus q over 2. And then the y-coordinate for this will be, once again, right where when you evaluate your function for that vertex. And so that would be the y-coordinate for your vertex, just whatever your function evaluated at that coordinate. Okay, because of the symmetry, the line of symmetry is a vertical line through the x-coordinate of the vertex. So it's going to be x equals p plus q over 2. That would be your line of symmetry. And then going back to, once again, if we were looking for the y-intercept, as it will be for all, you're simply going to plug in 0 for x and evaluate your function. And that would be the coordinate for your y-intercept.